and then present. Everyone can see this?
Yes.
Good. Okay. So let's talk about how muscles act, how they interact, and how they're named. So muscle tissue, as you know, consists of contractile tissues. And this chapter focuses on how skeletal muscles interact with each other to bring about movement. How do we name the muscles? And leverage, the physiology of leverage. So, muscles can pull, they don't push. When one muscle group does something, and there is another group that undoes it. And the three main functional groups are the agonist, which is the prime mover, which is the muscle that is major responsibility for producing a specific movement. And also the antagonist, the muscle group or the muscle that opposes or reverses the particular movement. The interesting thing to know is that the agonist and the antagonist are located on the opposite side of the joints in which they act. Like flexion and extension, there are muscles on the flexion side of the joint, and there are muscles on the extension side of the joint. And those two movements are against each other, flexion and extension. All right? A third type of muscle is a synergist, and the synergist helps the prime movers. It adds extra force to the same movement. It reduces unnecessary or undesirable movement. There is a type of synergist called a fixator that immobilizes bone or the muscle's origin rather than enhancing the movement of the prime movers. It actually gives a stable base for the prime mover to act. So those are the three types of muscle actions: agonist, antagonist, and synergist. Okay? And you can kind of look at where these muscles are. If a muscle is on the anterior side of the joint, like the pectoralis major, which is right here, it produces flexion, pectoralis major. It's on the anterior side of the joint. If the muscle is on the posterior side of the joint, like the latissimus dorsi in my back, it will produce extension. So an anterior muscle produces flexion, and a posterior muscle produces extension. All right? Now, what if the muscle is on the lateral side of the joint? If the muscle is on the lateral side of the joint, it produces what we call abduction. It makes the arm go away or the leg go away from the body. And that's what your deltoids are there for, to move the arm away from the body. And that is on the lateral side of the joint. If the muscle is on the medial side of the joint, you bring the arm towards the body, and that's known as adduction. Abduction is away, adduction is towards the body. Abduction is on the lateral side, adduction is on the medial side. Muscles act in groups. The same muscle in a group can be the prime mover in flexion or the antagonist in extension or the synergist in lateral or medial movement. So the same muscle can act as all three, the prime mover, the antagonist, or the synergist. All right? How do we name muscles? Well, the majority of muscles are named for these three things: location, shape, and size. Muscle location. The temporalis muscle is right here over my temporal bone. That's why it's called the temporalis muscle. Muscle also are named for their shapes. The deltoid muscle in the arm and chest is named the deltoid because the word deltoid in Latin means triangle and is triangular shape. The muscle can also be named for its size. Maximus, meaning the biggest, minimus, meaning the smallest, and longus, meaning the longest. And the shortest is a word called brevis, brevis. So maximus, minimus, longus, and brevis are the actual size of the muscles. Can also be named for the direction that the muscle fascicles lie in. If the fibers run straight, it's called a rectus muscle. If the fibers run at a right angle, it's called transversus. And if the fibers run at angles to an imaginary axis, it's called oblique. It also can be named from the number of origins. The biceps, bi meaning two, has two origins. The triceps, meaning three, has three origins. And the quadriceps has four origins. We can also name them for where they are attached. Naming according to the point of origin and insertion, but we always name the muscle origin first. For example, the sternocleidomastoid. It attaches to your sternum and your clavicle, sternocleidoid. Its origin is in your sternum and clavicle, and its insertion is in the mastoid process. Sternocleidomastoid. This muscle turns your head. And we'll talk more about that on Wednesday. Also, it can be named from the muscle action that it produces, whether it's a flexor or an extensor. And several criteria can be combined. There is a muscle in the wrist called the extensor carpi radialis longus. Extensor, it means it extends. Carpi, it means it extends the wrist. Radialis, it means it's on the radial side of the wrist. And longus, it's long. And yes, there is an extensor carpi radialis brevis, which means it's short. So these are the criteria for naming muscles, and we will go over the muscle chart on Wednesday, and we'll talk about the muscles that I think you should remember, not only for the exam, but also as you walk out of this class in May. How are the fascicles arranged? Remember, all muscles consist of bundles of fibers, and these bundles of fibers are known as fascicles. The arrangements in different shapes gives the muscle its functional capability. The most common patterns of arrangements are circular, convergent, parallel, and pinnate. And here they are. Here's circular, just like a circle. Here's convergent, they all come together. Here is fusiform, okay, fusiform like a spindle. Here's parallel, and here's pinnate. The word pinnate should make you think of a flag. Make you think of a flag, okay? And here they are. And this is where they lie. This is where they lie. Circular, convergent, fusiform, parallel, and pinnate. Pinnate. Circular, well, they're all in circles. They're in rings. And the most common example of a circular muscle is the muscle of the mouth, the muscle of the lips, the orbicularis oris. It actually allows you to whistle. The orbicularis oris. Convergent. Convergent is a very broad arrangement. And the most common convergent muscle in your body is the pectoralis major, which is right here in your anterior chest, a very large muscle. All right? Here is the orbicularis oris, a circular muscle, right here, and this is where it is. Convergent, here it is, the pectoralis major, it's right here in your anterior chest. Parallel, the fibers are parallel to the long axis, and the muscle looks like a strap. And the typical example of that muscle is the sartorius muscle in your leg. Fusiform, spindle-shaped muscles. The most common example of a spindle-shaped muscles is your biceps, right here, biceps brachii. Fusiform, biceps brachii, here it is, right here. All right, fusiform, spindle-shaped muscle. And the sartorius, which is a parallel muscle in your leg, the sartorius. Pinnate, you don't really have to know the three forms. That's not important. What you should know about pinnate is that there are short fascicles that obliquely run across the central tendon of the muscle. These muscles look like flags. And the number one example of a pinnate muscle is the rectus femoris in your leg. Okay? The rectus femoris. This is the deltoid. The deltoid is a multi-pinnate muscle. Don't worry about multi-pinnate. That's not important. Bipinnate is not important either, but it looks like a flag. Looks like a flag. This is the rectus femoris. And then you also have another flag-like muscle the extensor digitorum longus. And let's focus on these words. Extensor, it means it extends. Digitorum, your digits, your fingers, and it's a long muscle. It allows you to do this. It allows you to do this. Okay? Your digits are also in your feet. So this muscle, the extensor digitoris longus, is in your leg, but it allows you to extend your toes. Extensor digitorum longus. The most common patterns, and those are the ones I want you to know, are circular, convergent, parallel, fusiform, and pennate. And that's all you have to know on this slide. Just know the most common patterns of muscle fascicle arrangements. Okay? But what I want you to know is that muscles act as levers. They move objects, your body, by leverage. So we must talk about the physiology of a lever. So the lever system has three components. The lever, which is the rigid bar, in this case it's bone, that moves on a fixed joint called the fulcrum, which is the joint itself. The effort is the force supplied by muscle contraction applied to the lever to move resistance. And that resistance is known as the load. And the load, which is resistance, is moved by effort. So you have lever, effort, and load. Remember the definitions of those three words, because that is the leverage system. Levers allow given effort to move heavier load or to move load faster or farther. You either have a mechanical advantage or a mechanical disadvantage. If you have a mechanical advantage, you are dealing with a power lever. The load is closer to the fulcrum, with the effort being far away from the fulcrum. A small effort can therefore move a larger load. That is a mechanical advantage. If you have a mechanical advantage, it's called a speed lever. The load is far from the fulcrum, and the effort is close to the fulcrum. The load is moved rapidly, speed, over a large distance, and offers a wider range of motion. The basic principles of levers: the effort farther than the load from the fulcrum, the lever operates at a mechanical advantage. If the effort is nearer than the load to the fulcrum, the lever operates at a mechanical disadvantage. This is a power lever. This is a speed lever. Here are examples. Here's the load. Here's the fulcrum. For power levers, the effort is farther from the fulcrum than the load. Here's the effort. Here's the load. The effort is far away from the fulcrum. This results in a mechanical advantage. Thereby, you can move the rock because the effort is far away from the fulcrum. This is a mechanical advantage. Here it is. Here's the load. Here's the fulcrum. The effort is far away. If the effort is closer to the fulcrum, there is a mechanical disadvantage. The effort closer to the fulcrum than the load is. This results in a mechanical disadvantage, but an increase in speed. An increase in speed. So you can see it here. Here's the load, here's the fulcrum, and the effort is closer to the fulcrum. A mechanical disadvantage, otherwise known as a speed lever. There are three classes of levers based on the position of the effort, the fulcrum, and the load. The first class lever, the fulcrum is between the load and the effort, equidistance. An example of that is a seesaw or a pair of scissors. Here it is. Here's the fulcrum. The load and the effort are equidistance apart, just like a pair of scissors. Just like a pair of scissors. First class lever. Okay? That's a first class lever. And one of the muscles that is a first class lever is the muscle that moves your head, and that is the sternocleidomastoid muscle. A second class lever, the load is between the fulcrum and the effort. And this is like a wheelbarrow. And in the body, it's like standing on your toes. Here is the load, here is the fulcrum, here is the effort, here is the fulcrum, here is the load, here is the effort. Standing on your toes. Here's the fulcrum, here's the load, here is the effort. Second class lever. Third class lever. Let me tell you already that a third class lever is the majority of your skeletal muscles. The effort is applied between the fulcrum and the load. Just like a tweezer or a forceps. And the majority of your skeletal muscles are third class levers. Okay? Here is the fulcrum. Here is the effort. Here is the load. It acts like a tweezer or a forceps. Here's the fulcrum. Here's the effort. Here's the load. The majority of skeletal muscles are third class levers. Here's your elbow, which is the fulcrum. Here is the load when you lift weights. And here is the effort. And this effort is the biceps brachii. And this is flexion. Flexion the forearm. Here it is. Majority of skeletal muscles are third class levers. Okay? So the summary, in mechanical disadvantage, speed levers, force is lost, but speed and range of movement are gained. Systems operating under mechanical advantage, power levers, are slower but more stable. Power levers, as the word says, are used when strength is a priority. Okay? Now, there are 600 muscles. You don't have to know 600 muscles. You may have to know 100 of them, but not 600 of them. Okay? And we will talk about these muscles. What I want you to know about muscles is their function. You don't have to know what bone they originate from, what bone they're inserted on. I want you to know their function. I also want you to know the definition of origin and insertion, but I want you to know their function. On Wednesday, we will go over the muscle chart. It's a chart that shows you the muscle, the function, the innervation, the insertion, and the origin. The only thing I want you to know on that chart is the name of the muscle and its function. You don't have to know the innervation, you don't have to know the origin, and you don't have to know the insertion. Tell me the function. On exam number 4, I'm going to give you a muscle and you're going to tell me the function. Okay? So basically, that is chapter 10. So let's get away from this. And also, let me stop recording. But we do have time